Welcome to the Explainer. Today, we're jumping into Dart's really unique take on object-oriented programming, OOP. We're going to look at how its simple but super powerful features, from single inheritance to these awesome superpower-like mixins, help developers build really clean, well-structured apps.
So let's kick things off with a challenge that every single developer runs into. How do you take something from the real world, like a point on a map or a bank account, and build a solid, reliable digital version of it inside a program? Well, a really popular way to do this is with object-oriented programming. It's all about designing your software around these objects. And in Dart, this is absolutely fundamental. I mean, every single thing is an object, and every one of those objects is an instance of a class. Everything traces back to a top-level class called, you guessed it, object. So let's start with the cornerstone of it all, the class itself.
Okay, so the most basic tool we have in our OOP toolkit is the class. And it's really important to think of it not as the object itself, but as the blueprint that you use to create objects. Check this out. This is a perfect, super concise example right from the Dart documentation. This is our blueprint for a point object. It says that any point we create is going to have two coordinates, an x and a y. And that second line there, the point this.x, this.y part, that's the constructor. Think of it like the special recipe that gets followed every time you want to make a new point object. It just sets up those initial values for you. So when you boil it down, every class blueprint has these three key parts. You've got your instance variables, that's the data, the stuff it knows. Then you have methods, which are the functions that let the object actually do things. And finally, you have the constructors, which are the instructions for how to build a brand new object from that blueprint.
Okay, but what happens when you need to protect an object's data? I mean, you wouldn't want the balance of a bank account to just be accidentally set to a negative number from anywhere in your code, right? That'd be chaos.
And this brings us to a really crucial idea. The problem is that if you let anyone and everyone access your data, you're going to end up with messy, unpredictable bugs. The solution is something called encapsulation. It basically acts like a vault for our data, bundling it up with the methods that are allowed to change it and hiding all the internal details from the outside world. Now, what's really cool is how Dart handles this privacy. A lot of other languages use special keywords like public or private. Dart, it just uses a simple convention. If you pop an underscore in front of a variable or a method name, bam, it's now private to its library. It's this clean, elegant signal to other developers that says, hey, this is internal stuff, probably best not to mess with it. So we then control access to these private variables using getters and setters. A getter lets other parts of your code read the value of that private underscore balance, and a setter lets you modify it. But, and this is the really important part, it lets you add some logic, some rules. For instance, inside your setter, you could add a quick check to make sure the new balance amount isn't a negative number. Super useful. Okay, so we can create blueprints and we can protect them. But how do we build on top of them to create more specialized versions? And maybe more importantly, how do we reuse our code across different blueprints without just resorting to copy and paste? All right, first things first, let's clear up something that trips up a lot of developers, especially if they're coming from a language like C++. Dart made a very intentional choice to avoid the complexities of multiple inheritance. You just can't have one class inheriting its actual code from a bunch of different parent classes. It keeps the whole family tree of your classes much simpler and easier to follow. So the bottom line is that Dart uses single inheritance. You use the extends keyword, and that lets you create a more specialized version of another class. You might have a musician class, for example, that extends a more general performer class. That means the musician automatically gets all the stuff a performer has, and then it can add its own unique musical behaviors on top. Well, that leads to a pretty big question, doesn't it? If we can only extend one class, how on earth do we share common functionality? What if you've got a bird class and a superhero class, and you want both of them to be able to fly, but you don't want to write that fly code twice? This is where Dart has just a brilliant answer: Mixins. A mixin is basically a chunk of reusable code, a little package of methods and properties that you can mix into any class you want. It's almost like adding a superpower or a new skill set directly onto your class blueprint, completely separate from inheritance. And the way you do it is just so simple and elegant, you just use the with keyword. So here, our musician class is still extending performer, but it also gets all the capabilities that we've defined in that musical mix-in. And this is the key thing to get. It's not inheritance, it's more like composition. We're just adding behaviors from different places to build a more capable, more complete class.
All right, so let's do a quick recap of the toolkit Dart gives us. We've got classes as our basic blueprints. We have that simple underscore prefix that acts as a vault for our data. We have single inheritance using extends for creating specialized versions. And we have mixins using with for adding these powerful, reusable superpowers to any class we want.
So the real takeaway here is to think about how this really flexible model, this blend of simple inheritance and these composable mix-ins, gives you a totally different way to think about structuring your code. It really pushes you to build your features in these small, modular, reusable pieces. So the question is, how might that change the architecture of your next project?